Hello PreCalc. Here we are with lesson 9.5, the binomial theorem. Recall that a binomial is a polynomial that has two terms. Binomial, kind of like bicycle, we got two wheels, we got two terms. In this section we're going to study a formula that provides a quick method of raising a binomial to a power. To begin, look at the expansion of x plus y to the nth power for several values of n. So to the 0 power, anything to the 0 power is 1. To the first power, we just have x plus y. To the second power, we should still know this one, x squared plus y squared, and then 2 times xy in the middle. Okay, after this, it's probably not like memorized knowledge, but it could be. X to the third, 3x squared y to the first, 3x to the first y squared, and then y to the third. Parentheses to the fourth power, we have x to the fourth, 4x to the third, y to the first, 6x squared y squared, 4x to the first, y to the third, and then y to the fourth, and you can read the fifth power one. Notice some observations that we can make about these. In each expansion there are n plus 1 terms. So to the 0 power we have 1 term. To the first power we have 2 terms. Second power we have 3 terms, and so on. In each expansion, x and y have symmetrical roles. The powers of x decrease by 1 as we move on, and the powers of y increase by 1. And that's just because, so whatever one's in front is going to be the one that decreases. It starts off with the biggest and then decreases, and whatever one's in the back will start off with to the 0 power and then grow as you go. So like to the 5th power, x is to the 5th power, there is no y. And then x is to the 4th power, it goes down 1, and now y is to the 1st. X is to the 3rd power, it goes down 1, y goes up 1 to y squared. And while you're looking at that, also note that the exponents on the variables will always add to the power of the binomial. So that was to the 5th power, so all of these exponents will add to the 5th power. And the coefficients, the numbers in the front, the coefficients increase and decrease in a symmetric pattern. Okay, the coefficients of the binomial expansion are called the binomial coefficients. To find them, we can use the binomial theorem, which is going to use combinations, which is why we talked about factorial earlier. Okay, the number of combinations taken r ways will have n factorial over n minus r factorial times r factorial. Sometimes it's shorthand with parentheses around n over r, and we have this button on our calculator too that you can double check yourself. For the first couple here we're going to do it by hand, so you can see what this is like by hand, and then for future applications we can probably just use our calculator. Okay, so the front number is your n, the back number is your r, so we have 8 combinations, 2 ways here. We're going to have 8 factorial on the top over 8 minus 2 factorial times 2 factorial. So I have 8 factorial over 6 factorial times 2 factorial. And remember, our factorial is simplifying. 8 factorial is really 8 times 7 times 6 dot dot dot. Well, we have 6 dot 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 down here. Running out of space. So the 6 factorials will cancel out. 8 times 7 is 56. 2 factorial, 2 times 1 is 2. And we'll finish with 28. Okay? You could probably maybe do this step mentally and not have to write it down, but let's have you push pause and try B. Alright, so with B, we should have 10 factorial over 7 factorial times 3 factorial. We're going to expand 10 out a little bit. 10 times 9 times 8 times 7 down will be 7 factorial over 7 factorial. Those will cancel. And then we have 3 factorial left. So 10 times 9 times 8 over 3 times 2 times 1 should be 120. Some special cases over here. They're both about the same thing. 7 combinations 0 ways. Okay, so we have 7 factorial on the top. 7 minus 0 times 0 factorial. Okay, so you'll have 7 factorial over 7 factorial times 0 factorial. Remember that it's kind of a cheater method here. Not that we did it or I did it, but the rule is with 0 factorial it's still 1. Otherwise a lot of things fall apart. So 0 factorial is technically 1. And then those will cancel each other out, and we'll have 1 over 1, or just 1. And we should get the same thing over here, just that the 0 switches spots to the front number. All right, so working on some factorial simplification. When r doesn't equal 0 and r does not equal n, because if r equals n, you will still get a 0. As in parts A and B, there is a simple pattern for evaluating binomial coefficients that works because there will always be a factorial terms that divide out, kind of how we had those canceling out. There is a convenient way to remember the pattern for binomial coefficients. By arranging the coefficients in a triangular pattern, you obtain the following array called Pascal's triangle. Also an excellent tattoo choice, along with your quadratic formula and such. The unit circle, okay? Very useful. So it starts off with a 1, and then we keep going 1s on the outside for each row. And then every other term is made up by adding the 2 diagonally above it. So 1 plus 1 is 2. 1 plus 2 makes 3. You can see they've kind of outlined 4 and 6 makes 10 below it. Pascal noticed the numbers in this triangle are the same numbers of the coefficients of a binomial expansion. So if you have something to the 0 power, or the 0th row, okay, it's 1. Okay, we really don't think about that when we don't necessarily need it. The first row, anything to the first power, we're going to have that term 1 and another 1 coefficient on those. We'll see we'll have 1x and 1y. The second row is the squared row. You'll have 1x squared, 1, 2, 1, 1, 2, 1. We'll have 1x squared, 2xy, and 1y squared. They're giving you the numbers in the front. The third row, or the 1, 3 row, is your cube row. 1x to the third, 3x squared y, 3xy squared, and 1y to the third. So what I do is I'm thinking, okay, what is the power? If I have something parentheses to the 5th power, I'm looking for the row that goes 1, 5. And there's my coefficients. 1, 5, 10, 10, 5, 1. Okay, we talked about that. Alright, use the 7th row to find the next row, or the 8th row, for all of our pieces. Okay, we know the outsides are 1s. And now the rest of these are going to be made up by adding them together. Go ahead and push pause and fill in the rest of the spots. Alright, 1 and 7 should make 8. 7 and 21 is 28. 56. 70. 56. 28. And 8. So if you were doing parentheses to the 8th power, a binomial to the 8th power, your first coefficient would be a 1, then we'd have 8, and these would all be the coefficients of all the spots as you go. When you write out the coefficients for a binomial raised to a power, you are expanding a binomial. The formula for binomial coefficients can give you an easy way to expand them, as demonstrated in the next examples. Onward! Alright, write the expansion of the expression x plus 1 to the third. Alright, so we're thinking about the 1, 3 row from our triangle. So 1, 3, 3, 1. Those are going to be our coefficients. I'm going to go big spaces in between so you can really see what's happening here. So we have 1, 3, 3, 1. Then our front number, our front piece of the binomial, starts off with whatever that is to the biggest power. So we'll have x to the third, and then it drops down, x to the second, x to the first, and x to the 0, which we know is going to be 1. The next piece goes in reverse. So 1 to the 0, 1 to the 1, 1 to the second, and 1 to the third. Now they are nice to us and gave us 1, in which 1 to all these powers is just going to be 1. So nothing really changes here, but you can see how things could get pretty big pretty quickly here. So we have a 1, and x to the third. And this is a plus, so all these will be plus. Sorry. If it was a minus, they would alternate. We're going to talk about that in the next one. Okay, then we have 3 times x squared times 1. So 3x squared. 3 times x to the first, 1 squared is still 1. So plus 3x. 1 times 1 times 1 is 1. So x plus 1 to the third power is going to be x to the third plus 3x squared plus 3x plus 1. To expand binomials that have differences or minuses, you alternate signs. Okay, it's always going to be positive on the first, and then it goes minus, plus, all the way down. Okay? Let's do B together. It's kind of the more difficult one, and then hopefully you should be able to do A on your own. We'll walk ourselves through B. Okay, what makes B tougher, number 1, it's flip-flopped. Okay, well, they both have variables, I guess, so it doesn't matter. But number 2, there is a coefficient already in there with that term. So we're going to the fourth power. So we're looking for the 1, 4 row. Okay, 1, 4, 6, 4, 1. And if you forget this, it's pretty easy to make up on your own for like a quiz or a test and go down like 5 or 6 rows. But the fourth row is 1, 4, 6, 4, 1. So I've got 1, 4, 6, 4, 1. Oops, not enough space over there. Sorry, guys. Okay. Well, you're going to need it for that one too, aren't we? 1, 4, 6, 4, 1. Falling apart. Okay, second, we're going to take the front spot, and that grouping, because it's not by itself, is all going to start at the highest power. So we're going to have 2x to the fourth. So we have to take both pieces of that to the fourth. That's why this one's a little bit more challenging. The one above it should be easier because there's not a number on that variable. Okay, 2x cubed. 2x squared. 2x to the first and 2x to the 0. Okay, even though it's going to be a 1, we know it's a 1. Do it. Write it out. Show the work. Then we have the back spot, which is y. That's going to start off with 0 power and climb up. And now we'll need to go through and put in it's a negative one, so we're going to put in our signs. So first one is positive, and then it's going to go minus, plus, minus, plus. Now we're ready to kind of simplify a row, and then maybe get an answer. I think we're going to need... Well, we'll see if we can do it. We'll see if we can do it in just one more row. Alright, so we have 1. And we have another 1. Y to the 0 is also 1. So 2 to the fourth power. We have to take both parts of that to the fourth power. So 2 to the fourth power, 2, 4, 8, 16, and then x to the fourth power. 16x to the fourth power. Minus, okay, we have y to the first, so we're going to have a y. 2x to the third, so that's 2, 4, 8, x to the third, times 4. So we're going to have 32, x to the third, y. Okay, 2 to the third was 8, and then we have the times 4 for 32. Plus 2x squared, so that's 4x squared times 6, 24 x squared y squared, minus 2x to the first is just 2x, times 4 is 8x, and then we have y to the third. 2x parentheses to the 0 power is 1. 1 times 1 is 1, times y to the fourth is just y to the fourth. Okay, so that's the process. This one above it should be a little bit easier because it doesn't have a number attached to that front variable. But it does have a number for the back spot instead of a variable. So you'll have some numbers to powers in there as well. Go ahead and give it a shot. Push pause and give it a go. Alright, let's see how you did. This is what I got. So again, we got our 1, 4, 6, 4, 1, because it was the fourth row, the 1, 4 row. Okay, and then we'll have y to the fourth, y to the third, y to the second, y to the first, y to the 0. And then we'll have 2 to the 0 climbing up. 2 to the 0, 2 to the first, 2 to the second, 2 to the third, 2 to the fourth. It was a minus, so positive, minus, plus, minus, plus. And then we simplify coming down. Okay, take a look at that. Freeze it if you need it. And we're moving on. Writing the expansion for 3 minus x squared to the third. So a little bit different here. The x to the third of the 1, 3 row goes 1, 3, 3, 1 from your triangle. And then we have 3 to all these powers. So 3 to the third. Oops, that's black again. Change colors. You don't have to change colors. I'm just trying to... I've really messed it up. We're just trying to do this so you can see all the different pieces. So we need 3 to the third in preferably red. And then we'll have 3 to the second, 3 to the first, and 3 to the 0. And now we'll have x squared, starting with a 0 and climbing up. It was a minus again, so we get to alternate our signs. Positive, negative, plus, minus, and now we're ready to simplify. 3 to the third is 27, times 1 is 27, so anything to the 0 power is a 1. So we're just going to have 27, minus, 3 squared is 9, times 3 is 27, x squared to the first power, well, 27 x squared. 3 to the first times 3 will have a plus 9. X squared squared. Remember, your power, parentheses power, we multiply powers. And our last one here, we have 1 times 1, and x squared to the third power, 2 parentheses cubed, power parentheses power, we multiply, minus x to the sixth. Okay? Next up, finding a specific term. Find the fifth term or find the coefficient. Okay, we can use that formula from the front. Sometimes you'll need a specific term. Instead of writing out the entire expansion, you can use the fact from your binomial theorem that r plus 1th term is, we have our combinations thing to get the coefficient, the first term to the n power minus r, and then the second term to the r power. Okay, so if we have the 8th power, we're doing the 8th parentheses to the 8th power, and we want to know the 5th term. Now, personally, I think it's easier just to go ahead and do the whole thing, or it's just as easy as to go through and think about all these pieces of it and remember this formula and how to do it. But it can be quicker if you remember how to do this. So we're trying to find the 5th term. So r plus 1 equals the 5th term. So our r number is 4. Okay, our power is 8. So we're going to do 8C4 on the calculator. That's your coefficient number, times, okay, we have a to the 8 minus 4 times 2b to the 4. So if we did the expansion of an 8th power binomial, the 5th term should be the whatever coefficient times something to the 4th times something to the 4th. Okay? On your calculator, nice message there. Your grade is doomed. We're going to go math, probability, and we want NCR, and when she gets the little things to fill in, we're going to go 8 and 4. So that number is 70. This will be a to the 4th. And 2 to the 4th, 2, 4, 8, 16. And b to the 4th. And then we can simplify by doing 70 times 16. And we'll have 1,120, a to the 4th, b to the 4th. Okay? And now instead of remembering how to do that, to me, for a smaller one, like even down to the 8th power, and I'm trying to do the 5th term, okay, I might do this all the way over to the 1, 2, 3, 4, 5, the 5th term for the a to the 8th row, the 8th power row. The 11th power, we're starting to get up there. We're starting to get up there, especially if it's A4, B7. So that's way down the line. That maybe it'd be easier to memorize that and have that process figured out. And then you have to remember if it's plus or minus with this one too. So that's fun. Alright, so go ahead and let's have a little challenge here for yourself. And go ahead and push pause and do your best here with this one. Alright, so let's talk about it. We're trying to find the coefficient, just the front number, just the coefficient overall of the 11th row. So definitely want to think about doing this one with the shortcut here. So your n number is 11, your r number is going to be 7, because it's giving you that up here. So I guess that's easier to think about than if they just said the 5th term. If they're giving you this, you know your back exponent is your r. So you're doing 11 combinations, 7 ways. We have the front one is going to be to the fourth, 2a to the fourth, and it looks like we can latch on the negative. If that'll take care of your plus or minuses, you can just latch on the negative with the back one, negative 3b parentheses to the seventh. That's another way there, so you don't have to think about alternating plus and minus. The exponent will take care of it for you. Your 11c7, 11 combination 7 ways, 330. 16a to the fourth, negative 2,187b to the seventh, and your coefficient will be negative 11,547,360. Alright, I'm not sure if they'd be this intense for the quiz or the test. Probably more in there. But still a good problem to push yourself. Alright, thanks for watching, folks. Let me know if you have any questions, and we'll see you next time.